Okay, so today, guys, we are solving for zeros. Please remember, any polynomial to an even degree is going to have the same end behavior. It's going to look like one of those two. Any polynomial with an odd degree is going to have opposite end behavior, where it's going to look something like that. They're all going to look something like that. Something else that I want to tell you guys that's not in the packet is all polynomials. I'm just going to abbreviate. All polys are continuous. You're not going to have any asymptotes, no gaps, no discontinuities whatsoever. Okay, let's talk about this little thing right here. This says find possible number of real zeros. Actually, we're going to find all the zeros. And the number of zeros is equal to the degree of the polynomial. The degree equals the zeros. The reason why we have the word real there is because imaginary is coming back. Imaginary is definitely coming back because we're solving stuff algebraically. We're going to find the turning points. The turning points are the degree minus 1. That's a change in direction. A change from increasing to decreasing or from decreasing to increasing. We're going to find the zeros. Y'all, I'm crossing out the word real because today we're finding all of them. You can handle it. To find the zeros of the function, we're going to set it equal to 0. We're going to factor and solve. All right, let's go ahead and get started. I'm going to kind of zoom in here. Give me a moment while I kind of maximize my space. All right, so we're going to look at the attributes, then we're going to solve. The first attribute we're going to talk about is end behavior. What kind of end behavior is this going to have? Up, up, down, down, or one arrow of each? What is this going to look like? Very good. Up, up. That's exactly what I was looking for. Let's just draw this. Good. The number of zeros is the highest degree. What is the highest degree? 4. That's how many zeros there are. We're going to go ahead and talk about the terms. We're not graphing it, but we can tell how many terms there will be. There's going to be a total of 3 terms because that's 1 less than the highest degree. The next thing that we're going to find is the y-intercept. Guys, the y-intercept for this is the constant. The constant is the term that doesn't have the x value. Is there a constant? Do you see just a regular number? No. What number means no? None. 0, 0. Remember, when every single term has an x, you know it goes to the origin every time. Okay, let's find the x-intercepts. The way we're going to find the x-intercepts is by factoring. Now, we just mentioned how they have an x. Actually, they all have an x squared. Let's factor out an x squared. So that's going to leave x squared minus x minus 20. If you don't factor twice on most of your stuff in pre-cal, then you're doing it wrong. Can I keep going here? Yes, yes, yes. So this is going to be x squared, x minus 5, x plus 4. Okay. So remember, I'm only showing this right here. I'm not showing this again. To find the zeros, you set each factor equal to 0 and solve. Guys, if you can do this in your head, do not write this down. You have plenty of other things to worry about. All right, so what times itself makes 0? 0. What's going to make that 0? Positive 5. What's going to make that 0? Negative 4. Look how I wrote that. That is the algebraically correct way to show the answers.
But then it's supposed to be 4. Is the square like 2 zeros?
Good question. Yeah. She's like, there's supposed to be 4. You're right. This one counts twice. So 1, 2, 3, 4. And we are going to get more specific about that on the next page. We're just kind of getting used to solving. We were able to see all of these attributes and solve for the equation. Let's look at B. What's the end behavior? Down, up. How many zeros? What's the highest degree? Yeah, 5. That's right. Turns. This graph is going to have 4 turns. Yeah, it's just 1 minus. Y-intercept. What's the y-intercept? 0, 0. Great job. Let's solve. Looks like we're going to take out x to the third out of all of these. So x to the third is going to leave 2x squared plus 11x minus 13. Guys, I'm going to slide and divide and solve on this. I'm going to multiply the front term by the back term. That's going to be negative 26. My top number is a positive 11. Are there any numbers that multiply to make a negative 26 but add to make an 11? Yeah, what we just used. Good job. Positive 13, negative 2. Y'all, look how I wrote those floating at the top of my little graphic organizer. I floated them at the top because I'm going to remind myself to divide by 2. Okay, so when we completely factor this, don't forget we factored out that x third in the beginning. This factor right here, 13 over 2, put the 2 in the front. So this is going to be 2x plus 13. This turns into minus 1. It's going to be x minus 1. So what is going to be the answers for this? It's going to be 0 because we factored out x to the third. What about this one? Yes. You know what? We love impropers. You can leave it as negative 13 over 2. But yes, you are correct. And then a positive 1. How many zeros were we supposed to have?
And 0. Oh, yeah.
We were supposed to have 5. I only wrote down 3, but remember that 0 is repeated 3 times. So I do have all 5 zeros accommodated for, or accounted for. Let's look at letter C. Okay, end behavior. Very good. I like how fast that was. All of us need to be that quick when we think about that. Zeros, how many? Yes. Turns. Yep. What's the y-intercept on this one? 0, negative 4. Yeah, don't change the sign on that. Okay, so they don't have a GCF or anything, so we're just going to go straight to factoring. So we're going to split up these x's evenly, y'all. Don't forget x squared in each parenthesis. What are the numbers that go in there? Minus 4 and plus 1. Yep, you're right. Can you keep going? Yep. That's a difference of 2 squares. X minus 2, x plus 2. Can we factor that thing?
No.
Good. Just bring it right back down. All right, so listen. You've got some real and you've got some imaginary. That's completely factored. I know x is going to equal a positive 2 and a negative 2. I know that if I graphed this, I would really see on a real coordinate grid, it would really go through the positive 2, 2 places to the right of the origin, and the negative 2, 2 places to the left of the origin. That's really going to happen. But there's more answers that will make this equal 0, and that's going to come from this. Y'all just told me it's not factorable. Guys, remember, if it's not factorable, you have to solve it like we did in junior high. Isolate the variable. The variable's not isolated, you got to move the 1 over. Do y'all remember what the square root of negative 1 is? It's I. So I'm about to draw a square root symbol. What else do I draw when I draw a square root symbol? Plus, minus. Yes, yes, yes. So x equals positive and negative I. So what are my answers here? Let me show you. 4 zeros. 1, 2, 3, 4. Let's take a look at the next one. All right, last one before we start graphing. All right, guys. So, and behavior. Super quick, what is it? Down, up. Yes, yes, yes. What about the zeros? Yep. 3 zeros. Turns. Yes, 2 turns. Y-intercept. Yep. Okay, let's figure out what's going on with the x's. We're going to have to factor. We can take a x out at the beginning. So let's write the trinomial x squared minus 6x minus 27. Can y'all keep going with that? Yes, you can. That's going to be x minus something. And then x plus something. Oh, I just wrote it. I was going to ask you guys, but I accidentally wrote it. What goes here? Yeah, minus 9. Now look, don't get difference of squares pre-programmed. Can you factor that? No, it's to the first power. It's done. So don't get like pre-programmed on that. You've got to pay attention to the degrees. All right, so let's talk about what x equals. It's going to equal a 0 for that. It's going to equal a positive 9 for the middle one. And then a negative 3 for my last factor that I wrote. All my zeros were real. So that's going to be the answer.